Hi everyone, it's nice to see you again, and today's lecture is about solving questions that goes from question 15 to question 20. The question is find the natural domain and graph the functions. We need to find the domain of each functions of these, and then we need to graph the function. We're not going to go in deep about how to graph the functions, because in chapter 3 in differentiation we will have a complete idea about how to graph the functions. But we're going to take some tips about how to graph the simple functions like these, or the well-known functions like the simple polynomials, square root functions, and the simple fractions, and so on. So we have question 15. We have the function f of x equals to 5 minus 2x. So the domain of this function f will be R, since it's a polynomial, and we have tips in our 3 lectures, the first 3 lectures, which is concepts and skills. We already know that the domain of the polynomial is always the all real numbers, and sometimes we can just write it that way. We can say just the domain of f, or without f, it doesn't matter, minus infinity to infinity, and these both forms denote the same concept. And I'm going to change the function to this formation. I'm going to write it y equal 5 minus 2x. To graph the line, we call this line, it's not a parabola, it's not a polynomial of degree more than 1. We call it line because it's linear, because it's the greatest exponent in the whole equation is just 1. If we have a y equal to of x, for example, y equal to x plus 2x squared, or y equals to square root of x plus 3, or square root of y equals to 3x minus 1. This is nonlinear, and this is nonlinear, and this equation is not linear because we have exponent which is not 1. We need all the exponent of the variable y and the variable x is just 1. And this is not linear equation because the exponents of x and y is not just 1. I have the exponent of y now 1, but the x, its exponent, the square root of x equal to x exponent to 1 divided by 2, which is half. It's not 1, it's just half. So I need them to be 1. And this is also is not a linear equation because y, the exponent of y just half is not 1. So I have a linear equation, and to graph the linear equation, you need to assume that x equals 0 and find intersection with y. So first we're going to put x equals 0 and find y. So we will put y 5 minus 2, and y will be 5 because 2 multiplies by 0 is just 0, so y 5. So the resultant is a point which is x equals 0 and y equal 5. That's called that's point y axis intersection. Okay, now let's call this A, B. We need to assume that y equals 0. I'm going to substitute it in here, so I will put y equals 0 and then 5 minus 2x. I will find the x, so x will be, I will move it to this side and divide by 2, 5 by 2. So the point will be 5 divided by 2, and the y is just 0. I will call this x-axis intersection. And to graph this function, need to graph x and y axes, and just to plot these 2 points. The first point is going to choose another color to make things clear. I'm going to choose this point, I'm going to graph it, and I'm going to choose this point and graph it. So this is y intersection because this is the x-axis, this is y-axis. So 0 and 5, 1, 2, 3, 4, 5, for example. This is the point 0.5, which is y-axis intersection. Okay, and the other point, 5 divided by 2 is 2.5. So 1, 2, 3, this is 2.5. This is 5 by 2, which is 2.5 on the x-axis and 0 on the y-axis. So the line will be the graph that goes through these 2 points, which is intersection with y and intersection with x. So this is, I would call it y equal to 5 minus 2x. So we completed the solution of the first point. Now we're moving to the next one, which is also a polynomial, but it's not as easy to plot as this one. It needs some procedure, a simple procedure to plot. So 16 f of x equals to 1 minus 2x plus or minus x squared. So it's not the domain. Let's start by the domain. I'm not going to waste time. The domain, all the real numbers, since it's a polynomial. Okay. The other thing, I need to plot this function. To plot it, I need to make a table. So I'm going to change this form to y, just to make it easier to you to recognize that this is the input and this is the output. And then I'm going to plot a table. I will choose 5 points because I have a curve here. Since the greatest exponent is not 1, I have x squared. The plot will be exponent. A curve. The plot will be a curve. So I'm going to choose x, and then the result will be y equal to minus 1 minus 2x plus x squared, okay? And I will get y, and after I get y, I will get x, y. So we're going to start by 0. When we substitute 0, 0, y will be 1. 1, 0, no, it's minus. Minus 0 squared, 1, and 0, 1. This is the first point. The next one, I'm going to choose 1 equal to 1 minus 2 by 1 minus 1 squared. So the result will be minus 1 goes with a plus 1, and the result will be minus 2. So the result will be 1 and minus 2. This is the second point. I'm going to take minus 1. So y will be 1 minus 2 minus 1 minus 1 squared. We can easily see the result that this is minus 1. We'll go with minus 1 because minus 1 squared will be plus 1, and we have already minus outside the brackets, so the result will be just minus 1 and a plus 1. We will eliminate this one, minus 1 multiplied by or by minus 2. The result will be just 2 minus 1 and 2. It's easy calculations. I'm going to take the plus 1 first. So y equal to 1 minus 2 plus 2, 2 squared. So the result will be I have here -4, -4, -8, and 1 -7. 2, -7 or -7, -2 here. Y1 -2, -2, -2 squared. That will be -4, that will be +4. The result will be just 1 because this one will goes the positive with the negative, and the result will be -2. And after I found the table, okay, we're going to plot these points. I think they're the highest one is just 1. Okay, so I'm going to, I think if you have just a grid paper, your plot will be clearer than mine. I'm going to plot the points 0, 1. This is 0 on x. This is 1 on y. And we have 1 and minus, 1 and -2. Okay, we have 1 and -2. So 1 here, -2. And we have -1 and 2. -1 here. No, I need to downgrade it, descale it. I'm going to choose that to be the 1. Okay, that to be the 1. This is the point, and I'm going just to make the scales smaller. Okay, this is the 1, and this is -2, -1, -1 here, and the result, and 2, -1 and 2 will be up there, because this is, we call it the maximum point, the highest point. And then we have just 2 and -7. We have 2 and -7 just up there, somewhere and down. And we have 2, we have -2 here, and we have just 1. -2 will be 1. -2 here will be 1. You don't need to graph it like a calculator. You just need to indicate the behavior of the function. So the graph will be that way, and from here it will be, remember, it's always a curve, always a curve. If you found an equation with exponent which is not all 1, if you have an equation that all exponents are 1, for example, the exponent of the y is 1, the exponent of the x's in the equation all 1, that will be a line. But if you found any kind of equation that contains exponent more than 1, 2, 3, 4, or contains squares, so the plot will be curves. Now we're going to solve the next question, which is 17. Gx equals to the square root of the absolute value for x. So we all know that to find the domain of this function, we need to put the expression inside the square root as greater than or equal 0. And we can easily find now that this happens when the domain of the function f is just all the real numbers, because we have no problems, we have no numbers that we're afraid of. We can just substitute any number in this, whether it was a positive or negative, because we have an absolute value that turns any negative value to positive value. Now we need to plot it. We know that this function consists of 2 functions. If you wanted to analyze, do an analysis to this function, it contains of 2 functions. How? It contains the, okay, let me choose the table method, because I don't want to go deep in some information that you don't need it right now. We don't need analysis right now. We're in the first chapter, and I don't want to go deep. I don't want to put you in a position that you face a lot of information that you don't want to know right now. So I'm going to do the table method. I'm going to take x as an input, and I'm going to apply the function here, which is y equal to the square root of the absolute value, and I will get y. After I get y, I will get points x and y, and then I'm going to plot them. So I'm going to take 0 and 1, and then minus 1. Okay, I'm going to make life easier here. I'm going to take 1 plus minus 1, and I'm going to take a plus minus 2, because it will be easy to plot since it's just a square root. So y equal of 0, the result will be 0, and the point will be 0 and 0. And a plus minus y equal to, I have 2 points here, plus 1 and minus 1. So I'm going to substitute them both here, because plus and minus 1, the result will be just 1. So plus and minus 1, the result will be 1. You need just to make to expand the table and make 2 rows. The first row is just 1, and then the second row minus 1. Here you can just expand it to 2 rows, plus 2 and minus 2. But just I'm trying to teach you something that you can invest your time, especially when you have an exam or a quiz or something. I have here the square root of plus 2, and the result will be always the square root for 2. So plus minus 2 will goes with the square root of 2. So now I need to plot. It's easy to plot. First, I'm going to take the first point, which is 0, 0, which is the origin. And then I'm going to take a plus 1, the result will be 1. So plus 1, the result will be 1. This is the point 1, 1. And let me make it a cross to be clear, or star, asterisk. And minus 1, it's also 1. That's why I took it a plus minus implicitly, because I know the absolute value will turn every minus 2 positive. Oh, minus 1 and 1. And the plus 2, the result will be the square root of 2, which is 1.4, about 1.5. I have half here, one about, approximately or roughly speaking, as they say. And here we have this 2, and I have just 1.5. Oh, my graph is not perfect, but I think it works. So the graph will be just a curve, because it's a square root. In the next section after these lectures, when we take the piecewise functions, we will know that the square root functions is just two functions implicitly. The square root function is just y equal to, when we open the absolute value, the result will be plus minus x. So y would divide 2, or y, this y, or g of x, contains two functions implicitly, which is the square root of x, which is this one, y equal, and the other function y equal the square root of minus x, which is this one. You don't need to know these things that I said lately. You need just to plot this table and plot these square roots, this one and this one. You don't need to tell him that this function is just or you don't need to tell him that this function, or tell the examiner that this function just consists of two functions that actually in it implicitly. You just need just graph it, just graph the function, and that's it. If the examiner told you to analyze this function or just to speak or discuss, you can say these things.